class, welcome back. Today we're going to talk about parabolas again. This time, though, I want to focus on more of the real-life application. As we look at something that's an object that has a shape like a paraboloid of revolution or a parabola, we're looking at an object whose surface is formed by actually rotating a parabola around the axis of symmetry. One cool thing about these is that if you have something in the shape of a parabola like this one, if you position a light, a sound wave, radio wave, etc., at that focus point in the parabola, the rays are going to reflect out of this point, and then once they bounce off of the parabola, they will run parallel to the axis of symmetry. So remember that an axis of symmetry is going to be that line that runs through the focus and through the vertex. And what this is saying is that if I place a light bulb here at the focus point, that the rays that reflect off that light bulb, when they hit the parabola, they will then bounce off that parabola, and they will always run parallel to that line of symmetry. And again, no matter where those rays hit, even if the ray hits out here, it's still going to bounce off and run exactly parallel. Vice versa, if we look at a satellite dish like this one, as rays come in and bounce off the satellite dish, those rays, no matter where they hit the satellite dish, will always bounce directly to this one point that we're actually referring to as that focus point again. So even if I had a ray that came in and hit the satellite dish right here at the end, it would still bounce straight to that one point. So using this, we can answer a couple of questions, and our first one is actually about a satellite dish like the one we mentioned. We find that the signals that emanate from this satellite in space strike the surface of the dish, and then they reflect to a single specific point, and that's where we're going to place this receiver. So think about what we just learned. If all of the rays are reflecting to this single point is what we're actually referring to as the focus. And we're placing the receiver at that point. So we're going to place the receiver at the focus point. Now it tells us that the dish is 8 feet across at the opening and 1 foot deep at the center, and we need to decide where should the receiver be placed. Now remember, the receiver is at the focus, so we're ultimately asking, where is the focus point? What's nice about working with these applications is that as long as we know the shape, we know it's a parabola, we can decide how we want to draw that parabola. Do we want it up? Do we want it down? Do we want it right? Do we want it left? It's totally up to you. For the sake of simplicity, I'm going to draw my parabola opening up, and I'm going to position my parabola, so that the vertex is right at the origin, making the numbers that we work with a little bit easier. Now, we know that this dish is 8 feet across at the opening. So we're going to say that the dish opens right here and that this distance is 8 feet across. Now, because parabolas are symmetrical, that means that from this side and this side, this has to be 4, this has to be -4 for that total distance of 8. We also know that the parabola is 1 foot deep at the center. So from this center here to the top of my my dish, this is 1 foot or 1 foot. So that means the y value here must be 1. Now with this information on a graph, we should be able to conclude that this ordered pair has an x value of 4 and a y value of 1. This ordered pair is -4, 1. What this is asking us to figure out is, where are we going to place the focus? The only thing that we know is that the focus has to be somewhere inside this parabola, but we don't really know where it is. So in order to figure out where the focus is going to go, we're going to have to write an equation for this parabola. Okay, now, using what we know about the parabola, since we know it's opening up, we know the equation is going to be in the form of x squared positive 4a and y. Since we've positioned the vertex at 0, 0, we can quickly plug in -0 to keep that nice and simple. And if we simplify this, we've got x squared equals 4ay. Unfortunately, we still don't know what the a value is, because we can't know the a value until we know the focus, and the focus is what we're trying to find. So instead, we're going to have to go back to substituting an ordered pair into the equation, and then we can solve for the a value. So we do have some ordered pairs that we can pick from. We've already established that this ordered pair as well as this one are on the parabola. So I'm going to go with the 4, 1 since they're nice easy numbers. And if I plug 4 in for x and 1 in for y, my equation is 16 equals 4a, which means I now know my a value of 4. Now, if I go back up to my equation then, my equation is x squared equals 4 times an a value of 4 times y. In other words, my equation is x squared equals 16y. Now, back to the question. Where should we replace the receiver? In other words, where should the focus be? So think about this a value. Remember that in a parabola, the a value tells you how far to go from the vertex to the focus point. So if I know that my a value is 4, that means that from this vertex, let me switch colors here, from this vertex, I'm going to have to go up 4 feet and place my focus right up there. So in answer to the question, the focus will be 4 feet above the vertex. Or actually, let's say 4 feet from the vertex, since we don't know what direction this satellite dish is actually pointing, but we do know that the focus is going to have to be 4 feet from the vertex, since that's our a value. Okay, looking at a second example, many of you have probably visited the St. Louis Arch, which is, of course, also the shape of a parabola. Now, in this example, I do want to point out the fact that this is a model of the St. Louis Arch. So as you're looking at the numbers, note that we are talking about a model. We know that the arch is 15 feet high at the center. So in this model, this distance from the center, this is 15 feet high. And we know that it is 40 feet wide at the base, so from here straight across, this is 40 feet. What we want to know is at what height, so keep in mind we're going to be solving for height in this problem. At what height above the base is the width going to be 20 feet? So we know down here at the bottom that the width is 40 feet. What I want to know is at what height will that width be 20 feet? That's what we're trying to figure out. So like we did with the last one, we're going to place this on a graph. And again, for simplicity's sake, I'm going to keep it pretty symmetrical, meaning, or I want to keep it kind of centered. So I'm going to place it right here so that the vertex is right there on that y-axis. Since the vertex is 15 feet high, I know that this is 15. Since I know that the base of the parabola is 40 feet across, I know that this must be 20 and this must be negative 20. Now, what it's asking us to figure out is where on this parabola will the width from one end to the other, when will this width be 20 feet? If you think about it in terms of numbers on the graph, if I want it to be 20 feet as a width, then that means that this has to be 10 and this has to be negative 10, so that the distance between them is 20. So think about what we're looking for here. I'm telling you that I know that the x value is 10, and we want to know what is that y value. Or on the other side, at negative 10, what is that y value? So just like we did before, we need to start with an equation. Okay, step 1 is almost always try to write an equation for your graph. And since this is a parabola opening down, we know the equation is going to be x minus something squared equals negative 4a. Remember, it's opening down. And then y minus something. Okay? In this problem, however, the vertex is not at 0, 0. In this problem, the vertex is at 0, 15. So when I go to plug that in, x minus 0, y minus 15. Now, we've got a pretty decent equation here, but just like in the last one, we still don't know the a value. So in order to find the a value, we're going to have to be able to plug in a point. Well, we did find a couple of other points on the graph. For example, right here, this point down at the base is at 20, 0. So if I plug in that point, and remember, we're going to plug in for x and y, I could plug in 20 for x, and I could plug in 0 for y. That leaves me with 20 squared equals negative 4a times negative 15. 20 squared is 400 equals 60a. And if I divide 400 by 60, I actually get about 6.6 repeating. So my a value is actually 6 2/3. And just for simplicity's sake, as an improper fraction, that is 20/3. So if we go back and write our equation back up to here, we now have an equation that says x squared equals negative 4 times a, and a is 20/3, times y minus 15. Or x squared equals negative 80/3 times y minus 15. So we've got an equation. Now, how do we use this equation? What we were asked to figure out is, at what height will the width be 20? So in other words, if I have an x value of 10, what is the y value? So I'm going to go back to my equation. I'm going to plug in my x value of 10, and I am trying to solve this equation for the y value. So if I solve, 100 equals negative 80/3 y minus 15. I'm going to multiply both sides by the reciprocal, so negative 3 over 80. And again, if I multiply this side, these become 1. This gives me negative 380ths equals y minus 15. Well, negative 300 divided by 80 is negative 3.75. When I add 15 to both sides, I get a y value of 11.25. Now, if we go back and think about, does this make sense? Since we knew that it was going to have to fall within that parabola, we knew that the height we're looking for had to be less than this 15. So that height of 11.25 does seem to kind of fit with where it might fall on this graph. Okay, final answer. At a height of 11.25 feet, the width will be 20 feet. Actually, this is all in, yep, this was in feet. Okay, one last example. Technically, this would have been a U try, but we're going to go through it together here. An experimental model for a suspension bridge, once again, we're talking about a model, is built in the shape of a parabolic arch. The towers are both 5 inches tall from the roadway. So again, if we start labeling some things on the picture, here's the road. The tower is 5 inches tall. We also know that the towers stand 60 inches apart. So from one tower to the next tower, this is 60 inches. Our job is to find the vertical distance. So look at the wording of that. Vertical distance, that's going to basically refer to the height. We want to find the height from the roadway to the cable at a point on the road 10 inches from the lowest point on the cable. Well, where is the lowest point on the cable? The lowest point on this cable is actually going to end up being the vertex of the graph. So what I'm asking is, if we are on a point on the road that is 10 inches from the vertex, so if I go over 10 inches, I want to know once I go over, let me switch colors here. Once I go over 10 inches, I want to know how high up will I actually be. This is what we're looking for, that height. So just like before, let's put it on a graph. Since we can kind of tell that it looks like this is a parabola that's opening up, again, I'm going to place the vertex at the origin just to keep things simple. We know that these towers, okay, we'll sketch that in here. We know that these towers are 5 inches high. So if I place 5 inches, I know that that's how high the towers are. I also know that those towers are 60 inches apart. Well, again, because of symmetry, that means that we're going to have to go 30 each direction. So think about the ordered pairs that we have right now. We have a vertex at 0, 0, and we have this point at 35 and this point at negative 35. And what am I trying to figure out? I'm trying to figure out if from the center here, or from the vertex, if I go over 10 units, so I want to go over 10 units, how high up will I be? So if you think about that in an ordered pair, I'm basically saying go over 10 units and tell me what's the height. I'm giving you the x value and I'm asking you again for the y value. So one last time, we're writing an equation here. When we write this equation, we know that this is a parabola opening up. So again, x squared equals positive 4ay. Our vertex this time is at 0, 0, so we can keep that simple. We don't know the a value, so my equation at this point looks like this. Like we did before, plug in one of our points, not the vertex, since we've already used that one. So we'll plug in the point 35, or 30 comma 5, which means our x is 30 and our y is 5. 900 equals 20a. And if I divide 900 by 20, I'm going to get 45. So I have an a value of 45. And if I take that a value and go back up here to my equation, x squared equals 4 times 45y. X squared equals 180y. So here's my equation. Now, how do I use the equation? I was being asked to find out the height when the x value is 10. So if I go 10 feet from the center. So we're going to plug in that 10 for x, and we are solving for the y value. When I do 100 divided by 180, I'm going to, oops, I hit the wrong button there. I'm going to get, looks like our y value is approximately 0.56 inches. So if I go over 10 feet, I'm only going to be at a height of about 0.56 inches. Now, might not seem like that's a real reasonable answer, but remember that it is going to start increasing faster as it goes up, and it's only going up to 5 inches. So we're already a little bit over half an inch, and we've only gone out 10 units at this point. So try a couple of these problems. Remember, think about some of the key details in terms of the format for the equation, what the purpose of the focus is, both in the equation and in real life. And always remember to write an equation